Hello, how are you? Welcome to Bromtech Engineering. I hope you're doing fine. The Lord has kept you well, and welcome as we are going to proceed with where we left. Last time we modeled, I showed you how to do your grid lines. I showed you how to do columns, beams, and slabs, and we left it at that. We did not find time to do our loads, analyze our structure, and design it. So today I'm going to show you how to load your elements and how you're going to analyze, so that you understand how to do the loadings and the analysis of your structure. Sorry for that. Yeah, so having done all these, I want us to observe our structure. You see, our structure has line loads because these walls are loading our slabs directly. Today I'm not going to show you how to do line loads. I'll just show you how to do the normal beams and how to multiply and generate your stories to the total number of floors that your structure has. And you also observe that we have a staircase here. I'm also not going to show you in this video, but there is another video we have done where we have shown you how to model this staircase here. So the line loads and the staircase, we are not going to do them today in this video, but they are in our other video whose link has been dropped in the comment section. So you have observed our structure, and this is it. Today we are going to start with loading because we have already done some modeling. Remember, there are also other things we have not modeled, like I've not showed you how to model lift slabs and any other things, shear walls, lift cores and all that, but those ones are in other videos. You can keep on checking in our channel. If we have not done it, we will done it soon. Let's start with loading. Once you have finished the modeling as we did from our last video, you go to loading, you do partition wall loads, and then you change the name here. Here we use Ndarugo blocks. Ndarugo is the name where is the quarry where the blocks are mined. They are normally 200 mm thick. They can be 150 depending on the size you want. So Ndarugo blocks, you can say clay bricks. You can do hollow blocks. You can also do concrete blocks. You don't have to name all of them, just name one which you're going to use and use it. But the reason why I'm doing this is to show you that you can have more than one type of wall in your structure. For instance, some people do blocks from the external perimeter, and then internal partitions they use clay bricks. But in areas like Nairobi, the capital city, finding clay bricks is normally not easy, but the blocks are readily available, so you can do blocks throughout the entire structure, or you can do hollow blocks where provided and all that. So after changing the name, you do dense blocks, or you could do medium blocks, light blocks, but for you to be safe, if you're not sure, use dense blocks. If you're using clay bricks, you can use medium blocks. Or you can use bricks, because bricks are also heavy. So because Ndarugo blocks are dense, use dense blocks, and then the unit weight is 20 for dense blocks. The layer thickness, you change this to 200 because our walls are 200 mm thick, and once you change this, you observe that this changes automatically. So if you have a wall of 150, it's going to change to 3 kilonewtons per meter squared. If you have a 100 millimeter wall, like the one we are going to load as line loads later on, then that automatically becomes 2 kilonewtons per meter squared. So with 200, we are going to have 4, and then you press OK. After you have set all these parameters, you remember you can also edit materials that you have in your library. You can define these for your own use, but for now we're going to use the ones we have defined here. So after defining them like that, you come and select a wall where you want to apply a load. You right click, and then you go to edit wall load. At edit wall load, you select the blocks you want. We want Ndarugo blocks, and then the wall height is 2.55 millimeters. 2.55 meters, because if you have a floor to floor height of 3 meters and you remove a beam of 450 millimeters, you will remain with 2.55 meters. But remember, the floor to floor height varies from structure. Some structures have 2.7 meters, others have 2.8, 2.85 and 3. So determine which one, but with 3 you will be safe in most cases, unless the structure has a floor to floor height of more than 3. Also, having said that, there is also something I think you should know. You can also define the wall length manually. Sometimes the wall does not cover end to end. You can select that box and then edit this length to whatever length you want your wall to have. Also, you can edit openings. I'll show you in another video how you can do a door or a window in a wall, but for you to be safe, just do full walls, so that, because you never know, sometimes the client or the developer might change a door, or the architect might change the position of a door or a window, and you had designed for a window to be at a certain place, and that is going to affect your design. So in most cases it is preferred you do 4 walls. That is why it is not preferred you use this, but if you want to be as accurate as possible, you can use this section. So you press OK after having selected that, and then you see you have already loaded this wall. Next is loading all the other walls. Now we don't have to do what we have done here, so that we load all the other walls. You can copy these. You can still load them manually like that, or you can copy wall load from the beam you have already put the wall load, and then you select your beams while pressing down the control press down the control button, select all the beams like that, physically like that. I'm going to show you a shortcut. You don't have to go through all this like that. Remember, I have pressed down the control button like that, like that, like that. These are balconies, therefore I'm not expecting to have full walls. Yeah. So, and then you right click and then you paste copied beam loads, because we had copied the load. It will ask you, wall load defined in the selected beam or beams will be replaced by wall load copied to the clipboard. Because we had already copied that, you say yes, and then it highlights them as red. That means we have loaded our walls with this load. Another option, instead of doing this, is let's go back, let's undo. I have undone. You see, I have only this one. Just copy wall load, come here to these beams, select the first beam, press down the control, select the first beam, press down the shift. Here now you need to press shift. I need to start this afresh. Press the first, press down the shift, and then select the last one, so it selects everything in between. If you want to select more than one, just select one and then press Ctrl, select one by one till you finish. So once you do that, it selects all beams, and then you right click and then you paste copied beam loads, then you say yes. So now a disadvantage with this is that you need to know these beams so that you do not select them when you're selecting this. Another option could be, after doing this, you select all these beams and then you delete the wall loads, or you change the height, because these ones have a balcony barrier which is normally like a meter high, so you can change the height of this. You can select that beam and then edit wall load. After editing wall load, you change this height to 1 meter, then you say okay, then you copy wall load, and then you select these beams while pressing down the control. Select these ones. so that you have a barrier there of 1 meter. All these depend on your structure, and as the civil engineer there are places where you're supposed to make a decision, because sometimes you don't have a full concrete wall here of 1 meter, you just have a parapet of maybe 200 mm, one course of masonry, and then you have steel balustrades or any other, or timber or any other barrier. So once you've selected that, you paste copied beam loads. Yes, so we have also pasted that, and the height is 1 meter, because if you select that and then you go to properties, no, not really, not properties, like that, and then you go edit wall load, see it is 1 meter. Okay, therefore we are done with loading of our beams. The second thing is to load our slabs. For us to load our slabs, you just select one slab, then you go to select and load properties. Here you go to loads, this is the self weight, enter value, this is the additional dead loads that you might want or incur in your slab, because this 3.6 has been calculated from the 150 millimeter depth of slab we have at that point. So because this is the reinforced concrete slab, remember you are going to do finishes and screeds and services on top of it, so the total load of the services and finishes is what you enter here. And from experience, if I do 1 to 2 kilonewtons per meter squared for the normal finishes are sufficient. If it is a residential structure, you can even do 1 kilonewtons per meter square. Sometimes you go to 1.2, or with me I prefer using 1.5, because sometimes you do a screed and then you do tiling and the thickness becomes a bit bigger. So 1.5 is sufficient. And then you do your imposed load. Imposed load for residential structures is normally 1.5. After that I do update and then close. So I have loaded this slab. Looking at this, it is very tedious. I cannot just start loading one by one till I finish. Of course I will finish, but I'll take more time. So an easier way is to go to slabs, right click, and then remember go to slab table, and then you see the height is there, the self load is there, but you remember we need additional loads, additional dead loads, and you have G dead. This is where you enter. Remember, this is the one where that we entered the value. It was slab number 7. But before you do this, you need to select your slab types. Let me explain what are slab types. Once you select a slab and then you load properties, there is this type that appears here. Slab types define the continuity at the edges of a slab, whether it is continuous or discontinuous. Slab type 1 is continuous in all the 4 edges. But you see, I have selected slab type 8. Slab type 8. It is discontinuous in one edge, and this is not true. This is simply because I modeled them like this. Therefore, I made an error in modeling. But don't worry. Instead of wasting a lot of time finding out the type of slab, this one could have fit into maybe slab type 2. Either slab type 2. Yes, it ought to be slab type 2 or 3. Either 2 or 3, because I'm not sure whether this edge or this edge is long. So if I start doing that, I'll take a lot of time. So what do you do after modeling? You come to slabs, and then you right click, and then you go to set slab types automatically, and then you do that in the whole story or in the model. But since we have only one story, you apply them in the story. Then you say okay. You see, let's check this properties. You see, it is slab type 3. And then this one, because it is continuous on all the 4 edges, it has to be slab type 1. See, it is slab type 1, and so on and so forth. So having set the slab types automatically, now we are going to loading. And for loading, we are not going to start loading one by one. That will take us time. And in cases where you have different utilities, that is where you're going to load one by one. If you want to load all of them, you go to slab, you right click, go to slab table, and then you see 3.6 has been calculated from the slab depth. If I change the depth to 200, the self is going to become 4.8 kilonewtons per meter squared. So this is calculated from what you have entered, and I've already explained how you do the additional dead loads. So I can start inputting additional of 1.5 in all slabs. I can do one by one, but since I don't want to waste time, I select all of them, and then I do 1.5. Sometimes when you have many slabs and the structure is big, and you are able to select, but once you select, you are not able to see all your selection, it will not change. This is changing because I'm able to select everything I'm seeing. Therefore, when it comes to that, select a few, change, select a few, change till you finish. But you can also edit one by one. You just select everything, you type your value, and then you're good to go. So for Q, this is the live load. The live load, you select the drop down. You see for residential it is 1.5. You can select that, but for you to save time, select everything and press 1.5. There you have your variable actions, as they are called in the Eurocode. Concrete cover is 25. You can change it to 30 or 20 depending on what you want to achieve. The rest you can leave them as default, and then you close. Once you do that, your slabs have been loaded, and you can confirm that. You go to properties, and then you go to loads. You see I have dead loads and impost live loads. Sometimes you can if the structure is not so heavy and you do not expect a lot of loads, you can change this additional dead load to 1.2 or even 1. So sometimes you have water tanks on your slab. You are supposed to treat them just the same way as normal slabs, but when you're doing loading, you are supposed to change the impost load, because water is a live load. Sometimes the tanks are empty. So I will show you how to do the calculation and how to do the impost live load in this very structure once we get to the roof. So once you are sure all your slabs are loaded well, so you remember my slabs are loaded and the beams are loaded, and I observe 3D. That is the way 3D is appearing. Remember these walls, I said they are going to be 1 meter high. Yes. Once I'm done with this, I hope you still remember we have not modeled our staircase, and these line loads will not model now, but I'll show you how to do that in a later video. For now, we're just going to do the structure so that you see how you model and you analyze it. After this, I have loaded my beams, my slabs. Now for columns, the columns are loaded automatically from the weight of the structure and from the loads you are entering in all the members. So for columns, you don't have to mind on how you're going to load them. After doing this, the next thing is to set my story height, come up with the whole model the way it's supposed to appear. But hope you remember, you observe, once I model a floor, it gives me columns carrying beams, and those beams carrying slabs, and those beams are loaded with walls. So if I model the next structure, the next floor, the columns are going to come to these walls that are existing here, and then the slabs are going to come on top of these walls. I'm going to show you. So you go back to building setout, you go to stories. In stories, there are many things you do. You can select a story, you can insert a story, remove, delete, generate, edit. But most of the common ones you will be using are insert story, generate story, and edit story. Insert story is going to you're going to enter the total number of stories you need. So here we can read, to add stories to the top of the building, enter a number greater than the current total. So if we enter like 6, we're going to have a total of 6 floors, including the one we have already. To insert an intermediate story, enter a number less than the current total. So if we had 5 and then you wanted to add 3, you want to add a floor on maybe 3rd floor, that is where you can use the second clause. But for me, I'm going to do 6 because I have 6 stories, and we are going to count. Remember, it is 6. We will observe how it will model total number of 6 stories. Once you say okay, of course these and the previous processes will not be undone after this step. Do you want to continue? Yes, I want to continue. They have not yet appeared. Remember what I did? I went to insert story and I'm done. After inserting, I go to edit story. Edit story is where I'm able to get the floor to floor heights. For instance, floor 1 is 3 meters. This is 333. I can even change this, let's say 1500, if I want this to be my foundation. Yes, there it is. If it maybe the ground floor has a higher floor height, 4, then you see it changes, and then these are cumulative. For now, I'm going to return them as 3000 millimeters. And you can describe, you can say this is ground floor. Here is a quick joke. You see, when you mention GF to people in other professionals, they might think you mean girlfriend. This means ground floor. To civil engineers, it is so special that it means ground floor and not girlfriend. So take that into consideration. That was on a light note anyway. So ground floor, and then this is first floor. This is second floor. This is third floor. This is fourth floor. And then this is fifth. Remember, we entered 6 stories. That means the ground floor is counted. Depending where you are, sometimes I think using our system, we start counting ground and then first. So when you model 6, it means your structure is ending on the 5th floor. After doing that, you can set the foundation depth. We normally say a minimum of 1500 millimeters. And then you can change any other thing that you feel you can change. But for now, I don't want to change many things. I'll show you later on how to maneuver all these things, how to change all this other stuff here. But for basic structures as this one, this is enough. And then you say okay. Remember, I have used insert story and I have used edit story. So another important one is generate story. For generate story, I need to generate, it means I need to multiply these. I've just modeled one. I need to multiply this to the rest of the floors. So you come and select this one, and you see it is X, and here it is a 0, because this is the source story and the target story. So my target story is story number 2 to story number 6. You can select all of them and select the things you want to be copied. Sometimes you even want columns alone, you don't want beams and slabs. So you just select columns and then you uncheck all these other boxes. I'm going to model maybe to the second floor, to the first floor, which is story number 2. You see, you say there is also something here. Replace existing columns, walls and beams at the same insertion in target story, because we only have one and we want it to be uniform. There is no need to check this. So for story number 2, you say okay. Hope you are observing what has happened. It has taken us to number 2. You can just do that to all the floors, or if you don't have time and you want to be quick, you can select everything and then you say wow, wait, here we just need to close first. Close. They cannot be generated because we have already generated them. So you see, now let me say my source story is still first. They are the same even if you select 2 or 1. Select everything and then say okay. It is going to do that. Actually, initially I could have selected story number 2 to 6 and it could have given me my whole structure, and then I say close. Sorry, I'm supposed to do that. Close. And then you see, hope you can observe I've modeled my structure. This is 1, 2, 3, 4, 5, 6. If you start counting from here, it is 1, 2, 3, 4, 5, 6. Therefore, depending on how you're doing your counting, kindly do not be confused. This is our 5-story structure with this as the ground floor. Sometimes this is a disclaimer. Sometimes you don't have beams on your ground floor. So what you do, you start modeling from the second floor, and then you finish. You start modeling from the first floor, but you do not replicate it on the second floor. You also model the second floor independently, and then you multiply. You generate the second floor to other stories. All these are just depending on how your structure is, site conditions, and your decisions as the engineer. So having modeled that, and I'm sure it is okay, the next thing I'm supposed to start doing is analysis. For analysis to happen, I need to start with checking whether my structure is okay. So I do a building model check, start. It is going to tell me if I have any errors, if I have any things which are overlapping and all that. You see the number of errors is 0. Then you close. That means my structure is okay, depending on the model check that they carry here. So from there, before I do building analysis, once I see this X, it means my building has not been analyzed. Therefore, I need to do a building analysis. Therefore, I start with pre-analysis. Just in this window, I go to edit materials, and then I have concrete columns. I change the class to the class I want 2530, and then you can say okay, 2530, that's okay. In terms of steel, grade 500 type 2 is what we have readily available here, and then I can state the bars that I want to appear in my columns. Generally, I want either T12, 16, 20 or 25 maximum. These ones are the most readily available in the market where I am. And then for concrete beams, I can also change the class to that, and then that is 500 type 2. Sometimes you might need to change this. It might come as 410 type 2, or it might come at 460 type 2, so you can change to what you want. And then for the rebar diameters for my beams, I'm going to remove all that and remain with the T12, T16, T20 and H25. And then for slabs, I also do the same thing. There you go, 500 type 2, yes. And then for rebars, for my slabs, I need, because they are solid slabs and the spans are not big, I need to have T10 and T8. And then for ribs, I don't have ribs, so there is no need. For links, we design using grade 250 plane. And then I need to have 10 and 8. For these, it's sufficient. Sometimes it might require you to go even to 12. So having checked all these, I go to foundation floor. Foundation concrete class is okay. I need this to be 500 type 2. And then I need to change my rebar diameters to start from 12 millimeters, 16 millimeters and 20. I want to use 20 as the maximum. And then for links, I'm going to use 250 plane, T8 or 10 or 12. That is sufficient, yes. And then for soil, let me say probably this is sand. Yeah, and then you say okay. Therefore, I have changed this to what I want in my structure. The second thing is to change the project parameters. You can change the design codes you want, but with Euro codes, I'm just okay. And then from there, you go to loading combinations, loading generator. In this case, because we are not doing wind analysis, you go to vertical loads, you just leave them the way they are, like that. And then you go to horizontal load combinations. because I don't want to do any notional loading. If you could have wanted wind, this is where you enter it, but here we don't want to do wind. You also don't want to do notional, and then you say okay. Therefore I'm going to have 3 load cases, and it will analyze and design using the critical load case. Then you press OK. Once I'm done with this, if I want to proceed with wind, if I had selected wind, this is where it is going to give me the parameters of my wind design. So after I'm done with that, I go to model options. Not really model option. Yes, if I might want to go to model options, change a few things here depending on what I want in my structure. But since we are not going into in-depth study of this, I'll show you what each of these means once we disintegrate them in another study. So once I'm done with that, you go to analysis now, and then you can run your building analysis. So I never want to design when analyzing. I always want to analyze, find out whether there is a problem first, and then design if I need to design the structure. So having selected analysis, you can wait. This depends on the strength of your computer. Sometimes if your computer is strong enough, it has a good RAM, this becomes quick. Mine is also not that bad. I'm able to do these works efficiently. So there it is analyzing. You have building analysis, data preparation, creating finite elements. It has done drift checks, they are completed. Wow, building analysis completed successfully. Once it is successful, you close. Then if there is an error in the analysis, or there is an element which is not properly modeled, you're going to have it stated here, or if there are nodes which are not properly modeled. So once you get these, you press OK, and then you close. It is loading, that is why it has disappeared. Yeah, you see now we have these checked. That means this has been analyzed. So you close. This is your free, we call it, is it a free body diagram? I tend to think so. It has nodes and your members. So to see this general behavior of your structure, you go to displacements, and then you do animation. You can see how your structure is not really failing. This is how you will have your deflections, your shears, and all that. So in this case, it is not that important. That means I have now analyzed the structure. All these members have their bending moments, their shear forces, and all that. I can also do those diagrams, and then you can see. But for now, I'm not here to concentrate really on that. I was here to show you how to do the analysis. Once you're done with the studying of the analysis, you can close this window, and then you can now proceed to design, because I'm done with analysis. In some complex structures where you have finite element floors, or you want to disintegrate your floors using finite element methods, or you have a raft foundation, you could proceed with the analysis. But for now, I want us to proceed to design. So in design, you can design columns, story beams, rebeams, foundation beams if they are existing, and all these other things. So for now, I would love to leave it there. Hope you have learnt a lot. Continue watching and following us even as we learn together. So in the next section, I'm going to show you now, after you have analyzed and you have your member forces and the moments, how are you going to design for them? How are you going to design for columns? If a column has failed, how are you going to make it pass? So we are going to design all that and see how you're going to generate your design reports before we start looking at the small details that might be required. So thank you very much. Hope you have enjoyed, you have learnt a lot, and I believe you're going to become better designers in this field. So continue following us, subscribe to our channel, press that bell icon for notifications from us, and don't hesitate if you have any comment, whether it be positive, where we have made an error. Just guide us, because we are also human beings and we might overlook one thing or another here and there. So thank you. May the good Lord bless and keep you. Till next time. Adios.